it's unfortunate, but painful chemo and radiation treatments are typically the norm for cancer patients. And when that doesn't work, there really aren't any other options. But a new treatment method under development in Baltimore right here is bringing some patients new hope.
Well, scientists may have discovered a new way to fight cancer. Instead of chemo and radiation, the patient's own immune system does the work. A team of scientists with the University of Maryland School of Medicine gave us an inside look at the research and how these next steps could play a role in fighting the deadly disease. For most cancer patients, treatment looks like this.
I've just been on different cocktails of chemotherapy. I had radiation. It's just been an up and down road, and right now my doctor he calls me his mystery patient.
But researchers at the University of Maryland are working on a new treatment to help the most challenging of cases. It uses the patient's own body to fight the disease. Dr. Arnab Banerjee spent about a year exploring immunotherapy, a new cancer treatment that, in theory, would be pain-free.
Well, in the short run, I think what it means is that patients who have already had chemotherapy and radiation therapy and still have their cancer, cancers that are not really treatable by other means, still have hope.
Hope is what Aaron Dean has held on to for years.
We came in expecting to hear remission and be very excited about it. My family came with me, and it was on my birthday, and he told me that it had come back.
She was diagnosed with Hodgkin's lymphoma 5 years ago. She's gone through just about every treatment in the book. She's the exact type of patient that could benefit from immunotherapy. A patient who hasn't quite found success in the traditional routes.
This is complete.
According to Dr. Banerjee, immunotherapy uses the patient's own immune system to fight cancer. An important part of your immune system is T cells. He says they're using these exact cells to fight off the sickness.
There's a protein inside T cells, in the nucleus of these cells, that we think is very important for programming those T cells to fight cancer.
The research is still in clinical trials, and they're looking into 2 separate ways to use your cells to fight your cancer. They're using medicines to reactivate T cells in tumors, and they're also able to take the T cells out, genetically engineer them, and reinfuse them back into the patient. The new therapy, Dr. Banerjee says, targets specific cells, unlike radiation and chemo that kill all cells in sight.
It sounds encouraging. I wouldn't wish some of the chemos that I've had on anyone. I would not wish how I felt on anyone as side effects from them. So something that wouldn't cause all the sickness and the pain, that would be incredible.
Dean knows all too well the side effects of traditional treatment.
I've been down to the point where I've been almost to zero with an immune system, fighting it, and I've had to wear masks, gloves.
Dr. Banerjee says not only would this new treatment be pain-free, reactivated T cells can travel throughout the body, targeting spots of cancer that haven't yet been detected.
We can get an idea of how activated T cells are by using this machine.
He's still looking into which T cells to target. It's research that could provide an alternative for patients like Aaron.
I was on the verge of very, some people would call it death, but I don't know what it was.
Dr. Banerjee hopes to use this research in more clinical trials within the next 5 years. For patients like Aaron, it's a beam of hope in the fight against cancer.
I know there's a light at the end of the tunnel. I just can't see it yet. And it's possible I may never will. But with my recurrent and resistant Hodgkin's, it's just very hard to see it right now.
Dr. Banerjee says in the early clinical trials of immunotherapy, they've seen good responses. He says there are success stories scattered throughout the country where patients have been cancer-free for at least 1 year. This month, Dr. Banerjee received a $250,000 grant from the Alliance for Cancer Gene Therapy to fund this breakthrough research.